Now let's do this example where it says that a network is having MTU of 576 bytes. So MTU is given to us, which is 576 bytes, which means what? MTU never ever contains IP header. Okay, so which means what? You need to subtract the IP header to get the actual data which you can transmit, like actual IP data. So the IP header is 20 bytes that is given to us. So you can say the IP data is 576 minus 20, which is 556 that you can transmit over the link. And the data part and the total data is basically 484. So just see here carefully, 20 bytes are the IP header and 484 is the data part in the IP. And how much data? So always deal in terms of data. So this is the data, right? And convert the MTU to data first, which means always subtract the IP header from the MTU to do this kinds of questions. So this is the IP data that you currently have, but the link is accepting the IP data of 556, which means you need to divide this into multiple parts, maybe three fragments, such that every of the fragment should not be exceeding more than 556. So this may be 556, this may be 556, and the remaining will be here, right? So this is the question. I hope you got it. Now, like there are two three points that I want to bring you in the notice. One is that IP header will not be included here, which means like IP header is not included in the 556. You need to deal in the data. This is the IP data that you have to divide in three parts such that each data is containing not more than 556. And then once you divide, then each fragment will be having separately IP header. So this is the IP header of each fragment, which is 20 bytes. And that like once you add that, then the total will be 576, which is equal to the MTU or not more than MTU at least, right? This is one thing. Another thing is that like just to tell you, it is not actually important just for this question, but just to tell you is that here if you notice that there will be some higher level protocol also, which means TCP, UDP, maybe ICMP, IGMP, like these kind of protocols header will be there. And this header is basically irrelevant to us, which means that you will not extract every header and not get the data at the application layer and then divide the data. So this header, if you notice, will only be included in the last fragment or one of the fragment, last or first, whatever you want to say. So this header will be included only in the last fragment, which means see, this first 556 bytes are here, this first 556 bytes, then 556 bytes, then some of the bytes which are remaining are this. So this header, which is let's say TCP header, will only be included in the last fragment only. So IP header is included in the every fragment, but TCP, UTP, or ICMP, IGMP, like anything which is which got encapsulated within this IP header will only be included in the last header or last packet. Okay, so anyway, this is not important for this question, but I just want to tell you in case if there is some question, so you should not get confused. Okay, in case if they say that suppose the TCP header is this much bytes, so it does not mean that you also need to append the TCP header everywhere. So you just need to work in the IP layer, which means, or in the network layer, which means every other detail is just abstraction for you. So you should not be dividing the data after the TCP or UDP. Okay, so this TCP header or UDP header will be the part of data only. I hope you got it. Now just to revise again, this is the 484 bytes of data at the IP layer you have, and this much bytes of data that our link can carry. So that's why this 484 should be divided into three parts. That is the first point. Now second point is that if you divide like this, then just tell me what will be the offset for each of the header. So obviously for this header offset is 0. Oh sorry, header means like packet. For this packet the offset is 0 because this packet is not following any byte. But what will the header or what will the offset for this packet? It will be 556, but as I told you that I always divide by 8, so it will be 566 divided by 8. So if you do that, then this 556 is not directly divisible by 8, which means this will be in the fractions. So I think this will be 69.5, which is not in the integers. So what you need to do, you always need to take care of this thing, which means you can, if you cannot divide by 8, then take the lowest possible, I mean just lower than this, which you can divide by 8. which means you should not be having 556, you should be having 552. So whenever you are dividing this 484 like anything into the number of packets, then do not divide if you are not having the multiple of 8. So always divide with the multiple of 8. So instead of 556, I will say 552, 552. Okay. See, you should like based on the IP data or based on the MTU that the link can carry is 556, but since you cannot divide this 556 by 8, that's why you will be dividing. You will be basically saying that this is 552, because if you divide by 8, then this will be 69. Like, oh, okay, you won't be dividing by 8 for the first packet, because the first packet offset is anyway 0. But yeah, if I talk about offset for the next packet, then it is 552 divided by 8, because it is following 552 bytes, which means 69. And what is the offset for this? It is basically following 552 into 2. It is following 552 into 2 divided by 8, which is basically 69 into 2, which is nothing but it will be 8 and 13. So 138. So it will be 138. And this is 552 divided by 8, which is just 69. And this will always be 0, because the first packet does not follow any data. And this is following 552. This is following 552 into 10 into 2. So you need to divide by 8. And what is this number? 552, 552. And I think this will be 380. So I hope you got it. This 484 should be divided into three parts. One is having 552 as a IP data length, and then 20 bytes of header, and then this will be having 552, and then 20 bytes of header. Then this will be again having 552 and then 20 bytes of header. Sorry, this is having 380 and 20 bytes of header. So that is all. That is all we needed to do in this question. And we are done with this question, right? Now let me write all the fields if you want me. So if you ask me the offset, then okay, let me go to the next page. So this 480 1480 1480 you have divided into three parts. One part is basically 552, and then obviously 20 byte of header. Another part is again 552 and obviously 20 bytes of header. Another part is 380 and 20 bytes of header. So basically 552 plus 552 plus 380 is nothing but 1480, right? This is one thing. Another thing is that we divided like we should be dividing such that each should not be having more than 566. So we should be dividing by 556. But since 556 was not divisible by 8, so I took the closest possible, which is 552. Okay, this is one thing. And now your fragmentation is done. Now if you ask me what are the fields that you should be having, so just tell me what is the total length here, total length of each packet. So this is 572 including the header, this is 572, this is 400. If you ask me MF bit, then MF bit, this is saying yes, more fragments are following, more fragments are following, no more fragments are following. If you ask me, let's say what are the other fields, offset, right? If you ask me offset, then I will say it is following just 0 bytes. It is following 552 bytes, which means 552 by 8, which means 69. It is following 552 and 552. So always count the data bytes. Okay. So it is following 552 into 2 by 8, which is nothing 138. So this is these are the two fields. There is one other field which is identification number for the fragments. So if you remember the fragment row, this was the three fields. One is identification number, offset, and this flags. So identification number, let's suppose is 100 for this, then it will be same for every other fragment, right? If you ask me the header length, then header length is basically same, which is 20. So header length will be containing just 5, because header length is 20. So the header length field will be containing, it is same for everything. So it will never be changed. These two things are basically same for every of the packet, right? This is 0 for last packet, and for every other packet this is 1. And offset you need to calculate. 0 is for first packet, and for every other packet it is something, right? So these are the fields that we have. I hope you got it. Now let me see the solution. Yeah, in the solution also fragment offsets are this, MF is this, and this is the original packet. And original packet is, let's suppose, having some X identification number that will get copied everywhere. And MF is 0 for the original packet, because the original packet does not follow anything, and actually this is the last packet. So if there is no fragmentation, then you say MF is 0. And initially the total length was 1504, and then it is basically 572, 572, 572 and 400, right? 572, 572 and 400. Initially the total length was basically 1484 plus 20, which is 1504, right? This is basically completely 1504. Now this is how we will be doing this question. Now let's say, let me extend this question, and let's say that when you are sending this packet, which is basically 20 and then 1484 over this network, which is let's suppose having the MTU was, what was that at MTU? MTU is 576, right? So this is 576 and then this is the router. Now let's suppose this again has to follow some route which is having the MTU even smaller. Maybe this time MTU is let's say this is 500. Okay, suppose this MTU is 500. So now what will happen? You have divided this into three packets. If you remember, one was this much, 552, and another was this much, 552, another was this much, 20, and then 380, right? You have divided into three packets. If this is 500, then this packet is okay, because the total length including this IP like IP header is just 400 and M2 is 500, which means there is no problem in that. Now if you see this packet, the total length is basically 572 and M2 is just 500, right? So it will not, these packets will not get passed through this network. So you need to divide these both packets. Let me take one of them because both are identical. So let me take one of them. This is 20, this is 552. You should be dividing into two parts. I think two parts will be enough. So M2 is 500, which means like the IP data it can hold is, if this is 20 bytes, so IP data it can hold is 480 bytes, right? So this should be 480. But whenever you are dividing, always make sure that this should be divisible by 8, because otherwise like offset won't be divisible by 8, because this packet will be having offset of 480 divided by 8. Since this is divisible by 8, so I do not have any problem. So this is 480, and let me subtract 552 and 480, so you will be getting 72, and this is 72, right? Now this may or may not be divisible by 8. Yeah, this is important. The last thing may or may not be divisible by 8, because this won't be offset for anything. So last packet can be having any data which is not divisible by 8, but yes, these should be divisible by 8, right? I mean, apart from last, this should be divisible by 8. So these are the two packets in which you will be dividing. This is 20, this is 20. Now this total is 500, M2 is 500, so that is okay. This total is 292 and M2 is 500, so this is also okay. So let me just write the total length. Total length you can write 92 and 500. And what will the more fragment? This will say 0, this will say 1. What is header length? Header length will be containing 55 for both of them. What is identification number? Identification number will be same as this, which is 100, let's suppose. So ID number is, let's suppose, 100. And what will the offset? Offset, this is not following anything. So first, this is the first packet, then this will be having offset of 0. This is following 480 bytes, so 480 upon 8, which is just 60. So offset is 60 here, right? I hope you got it. So this is how we can even fragment the fragmented packet further. Similarly, like these are the two packets. So similarly, this packet will also get fragmented in this way. So at this router, I will be getting two from this, and one. So 5 packets I will be getting. And suppose this is the destination, and this is the destination host. So I can reassemble these 5 packets. How? Based on the offset. So first I will be looking for the offset 0. Okay, so here, like let me go to this. So here this is having the offset 0, that is okay, right? Suppose this is the second packet which is having the offset 69. So this is the first packet, so offset 0 will work here. But suppose this is the second packet, then what will happen? Since this is the second packet, then this itself will be having the offset of 69, right? I hope you got it. So see, this is the first packet, let me just copy it. So there are two packets, right? Now this packet, if this packet is the first packet, this one, then the offset is anyway 0. Now for the second packet, this 20 552, everything will be same, which means this division will be same, which means 72 and 20. This division will be same, but the offset will be different, right? So it is following 552 bytes already, right? See here, this packet is already following 552 bytes, which means the offset for this is already 69, right? So this got divided into two. That is like that is no problem, because first packet is not following anything, but it is already following 552 bytes. So you will be saying that for the offset of this is anyway, like it is not 0, because it is following 52 bytes, which means offset for this is 69, and offsets for this will be, this is following 552 bytes plus 480 bytes upon 8, which means 69 plus 480 upon 8 will be 60, then it will be 129. So offset for this will be 129, offset for this will be 69. I hope you got it, right? Since there are two packets, and third packet will be this, which is 20 and 380, which is not got fragmented. So this packet is having offset of 0, this packet is having offset of 60, this packet is having offset of 69, this packet is having offset of 129, this packet is having offset of, like earlier what was the offset, the same will get copied. Earlier offset was 138, so this packet is having offset of 138, right? Now at the reassembly, it will search for the offset 0, then it will calculate the total number of bytes in this packet, apart from header. So this is 480, so it will search for the offset of 60 now, and then it will search for the offset of 69, then it will search for the offset of 129, then it will search for the offset of 138, and it will get a stop whenever it get find that okay, the MF bit is 1, MF bit is MF bit is 0. So at that point it will stop. That's how reassembly is happening. I hope you got it. So that's the G question, right?